Right guys, so as promised, I said I'd bring you through each experiment virtually. I know we've watched the videos and things like that, but this is just to give you a really rough indicator of any of the simple calculations. And this one, it's not too bad. It's all about ppm, grams, centimetres cubed, and most of these figures will be given to us in the question. So in the first part of this experiment, we're looking to look at the suspended solids, so things that are floating around. And if you even think about this in terms of water treatment and stuff like that, the easiest way for us to get rid of insoluble solids is by filtration. Okay, so that's exactly what we do. Now during this experiment, you get the mass, and remember mass is always grams. You'd get the mass of a dry sheet of filter paper. You would write that number down. You would filter your sample, and then you'd let it dry. And once you've it dried, you'd reweigh it again. And if there was a difference between those results, they're obviously any of the suspended solids that have been floating around. So these are the results that would have been in a sample set that I have. So the mass of our dry filter paper was 1.42 grams, so that was what you weighed before the experiment. And after the experiment, it was 1.60 grams. So to figure out the mass of my suspended solids, I take those two figures away from each other. And if there's a difference, which there is in this instance, of 0.18 grams, those grams must be the things that were floating around in our water sample, our suspended solids. So our answer for the next one, well, we have it down here. Now, the volume of the water sample that we use, for example, in this instance, is a litre. They would always have to tell you that in the question. So we want our answer, as you can see here, in ppm. So ppm means milligrams per litre. So we have the litre bit, that's fine, but we now need to worry about milligrams. Okay, so if you remember from our water hardness, grams to milligrams, we multiply by 1000. So to do that, we take our 0.18, we multiply it by 1000, and we get 180 ppm. Okay, so let's have a look at the questions relating to the experiment then. Suggest some possible causes of the high levels of the total suspended solids. Well guys, that could be due to anything. It could be due to positioning, so where the water is positioned. It could be due to algae growing in it. It could be produced down to sewerage in the water. Anything like that. The next question is what undesirable effects could result from high levels of total suspended solids? Well, you could damage, so I'm on question 2 now. You could damage any plants or animals that are growing in the water or living in the water. If it was algae, that's going to lead to that nice thing, I think you've done that in biology, eutrophication. And I know we have to talk about that, or finish talking about that, I should say. And part 3, question 3 even then, how are the particles removed in the water treatment? Well, this is in the settling tanks. In these settling tanks, you the gravity allows the suspended solids to fall as the sediment, and then anything that's left there is removed via filtration through sand and gravel. So the next part of the experiment that we want to do is to measure the dissolved solids, and the easiest way to do this is by evaporation. Now, when you're evaporating something in the method, they simply just put it into an oven. We know that you could pop it on a hot plate or you could pop it on a Bunsen burner and it would do the same thing. The really important thing is, again, like in the last step, you measure the beaker or the evaporation dish before and you measure it afterwards, and that way you'll be able to calculate the difference between the two, and that difference will be the suspended solids. Okay, so before, at the mass that we're using a beaker in this method, so the mass of the beaker before we put any water or anything into it was 99.05 grams, and then when you evaporated all the water sample off and you reweighed the beaker, it was 100.54 grams. So there's a difference there, and you take those away and you figure out that your difference is 1.49 grams. So that 1.49 grams must be the dissolved solids. So our dissolved solids were in 100 centimetres cubed. Again, we want our answer in parts per million, so we want milligrams per litre. Okay, so the first thing I'm going to do is, so we want to change our 1.49 grams per 100 to grams per litre. So the easiest way to do this is to multiply that by 10, so we get 14.9 grams, and our last step, grams to milligrams, we multiply by 1000. And our answer there becomes 14,900 milligrams per litre, or 14,900 ppm. If we have a quick look at the questions, guys, why must the water be filtered? The water must be filtered because if we don't filter it, any of the suspended solids, the things that don't dissolve, will still be floating around, and that won't be it won't give us an accurate result. Some reason for possible high levels of total dissolved solids: it could just contain really high levels of organic or inorganic salts. You could be in an area of a limestone area, and that limestone area the limestone calcium carbonate could dissolve into the water. It could be an indication that you're in an area where there's some domestic pollution, some agricultural pollution, or industrial pollution. And I'll do question 3 on the next slide. Okay, so a volume of 1,200 centimetres cubed of water was found to contain 0.09 grams of dissolved solids. We want to express this concentration in ppm. So the first step that we need to look at is we need to go from grams to milligrams. Okay, and the easiest way for us to do that is to multiply by 1,000. And that gives us 90 milligrams, but that's in 1,200 centimetres cubed. I don't want it in 1,200, I want it in a litre. So the easiest thing for us to do is to divide 90 by 1,200 and multiply it by 1,000. And by doing that, it converts it to a litre, and we get 75 milligrams, or we end up with 75 ppm. The last bit in all of this, guys, is to measure its pH. In fresh water, or water that we would be used to, your pH can range from anywhere from 6 to 8, and we know when we were doing our water treatment there last week, the pH is one of the last things that they test on it. Generally we want to keep it as close to neutral as we can, but if you're from an area where there's like a lot of limestone and stuff like that, that can cause it to be a bit basic. If you're near a bog, for example, if it could be quite acidic, it could be down to the 4s. So it just depends. This can affect the plant and animal life around it. Obviously most of the water coming in through the mains pipes will be as close to neutral as they can. There's a few ways of measuring your pH. You would use either your universal indicator paper, or we probably would use a pH meter in school. So relatively high pH, if you're looking at high pH, you're looking at a basic sample, so that could be in an area where you have really hard limestone or you have presence of algae. Alternatively, for question 2, some possible reasons for a relatively low pH: that it's quite acidic, or it's near a bog, or you have an awful lot of organic material breaking down there, so it could be a sign of pollution also.